Hey, hello everyone. How's it going? ¿Cómo están todos? Bien, gracias por venir. Hola a todos los que están en línea. Mi nombre es Roberto Rojas, como lo comentaba, soy originario de México, pero tengo un tiempo en los Estados Unidos haciendo software por un rato. Los dejo con mi compañero Nigel, luego vamos a empezar a interactuar. La idea de estar en persona es que nos hablen, hagan preguntas, tenemos suficiente tiempo. Let's take it off.
Hola, buenas tardes. Mi disculpas, mi español es muy malo, so I'm going to do this in English if that's okay. The presentation we have for you is how 50 organizations built Valkey. How many people were here for the last talk, Megan Knight's talk about open source community health? Okay, yeah, that's going to be, well, of course, you in the back were. But a lot of the things that she brought up about how people work together across open source projects is going to be what we're talking about in action with Valkey. How many people were in our earlier talk about Valkey? Okay, there's going to be some repeated information because we're going to talk about what Valkey actually is, what it is that we built. So Valkey, how many people have heard of Valkey before? Okay. How many people are using Valkey right now? Okay. How many people are going to use it after this talk? Yeah. You can lie. It's okay. So Valkey is an open source in-memory key value data store. It's high performant. It is your best option for a key value data store. I think I'm allowed to say that. The important things about the Valkey project is that Valkey started as a fork. There's a company called Redis that that was maintaining a database also called Redis. And last year they decided that they wanted to change the license of Redis from an open source license to a source available proprietary license. This upset a lot of community members who decided to fork the project and create Valkey. So Valkey is fully compatible with Redis open source 7.2, 7.2.4 to be specific, because that's where the fork happened. It's a vendor-neutral project. It's under the Linux Foundation. There's no one company that's in charge of it, one person that's making all the decisions about it. It's under a BSD3 license, and it's going to remain that way for the life of the project. And the project has diverse backing. There are a lot of companies that are involved in Valkey, and then there are 6 technical steering committee members from 6 different companies. So the project is really spread out around the globe and around different companies. So it's resilient in that way. That's one of the things that Megan talked about in her last talk. Speaking of the technical steering committee, we have companies like Tencent, Google, Alibaba, Huawei, Amazon, and Ericsson are the companies that form that technical steering committee. Up on the screen, I have some other companies that have given us permission to use their logo to say that they support the Valkey project. We have weekly meetings of the maintainers and contributors, and then another weekly meeting of an engagement group for companies that want to see Valkey be successful and are working together to bring about presences like us being here at this conference, or us being present in other places, or getting the word out about Valkey, how best to serve the community in that way. Valkey is growing. And it's a thriving project to begin with, but it's also growing. And one of the things that we wanted to talk about today, the title of the talk is, about how we have all of these different companies that are supporting Valkey, but beyond that, we have a lot of code contributors. We have a lot of contributors to not just the Valkey core project, but also to the supporting client libraries and related projects to Valkey. Over 1,000 commits across all the projects since the launch, 10 million container pools, and 10 companies that are, or at least 10 companies that are providing managed services for Valkey, if that's something that you're interested in. So like I said, Valkey is a hard fork of Redis 7.2.4. So if you're running any Redis version that is that or before, switching to Valkey is trivial. It's essentially just a name change. We're going to motivate for you why you should switch to Valkey and make that upgrade for your infrastructure. But some of the reasons are about how we have grown in the year and a piece that we've been around. So the Valkey 8.0 release was the first release under Valkey after the fork, which included things like getting up to 1 million requests per second that Valkey could handle, and that was on a much larger machine. We're doing that in our booth on a Raspberry Pi right now. Dual channel replication and enhanced slot migration reliability. And with our Valkey 8.1 release, we continued making improvements to reduce the memory overhead by about 20%, depending on your use case. We also added modules, which we're going to talk about in depth a little bit later. The modules that were initially added were vector similarity search, Bloom filter, and JSON modules, and then some changes for observability, including a new command log and metrics. And then what's coming in Valkey 9. Valkey 9 is soon to be released, and we'll talk about that as well. Multiple databases in cluster mode, atomic slot migration, and expiration on hash-filled items. So talking about Valkey 8 again, getting a little bit more into the specifics. What we show here is one example of a company who is using Valkey now, but initially they were using Redis. And they just made the switch from Redis to Valkey and used Valkey 8.0, which had, or 8.1, which had these memory improvements. And they were able to see their memory footprint go down by 20% by doing nothing else but just by switching to Valkey. Another thing that makes Valkey better, not just the memory efficiency that has been improved, but also the multi-threaded performance. There's a single loop or a single thread that is handling most of, well, that was handling everything. And what Valkey has done is offloaded the work of I/O to other threads to be able to raise the throughput of Valkey so that the system would be able to use a secondary thread just for I/O, and then the main thread could focus on what he needed to focus on. Was there anything you wanted to add to that? No? All right, cool. And then some charts about how the multi-threaded performance has been improved. So on the top chart, you'll see in the purple, the new I/O threads, bigger is better. In this example, where we're getting 3 times the throughput that Valkey can handle. Again, like I said, we have a Raspberry Pi demo that's handling 1 million requests per second. And then what also is a byproduct of that multi-threaded I/O is seeing the latency go down. So on the bottom chart, the smaller graph or the smaller bar is better. So we have much lower latency and much higher throughput. Again, with the improvements with 8.1, we implemented a new hash table. And you can see with the orange line is the overhead in Valkey 7.2, the green line in 8.0, and then 8.1 continually improving. Lower is better there. And then a bunch of other features that 8.1 introduced. There are a couple that are special to Roberto that I'll let him talk about.
Yep. So, the audio? Okay, can you hear me? Perfect. So one of them is the TLS negotiation. Usually, very often, the bottleneck on CPU is going to be establishing a lot of new connections, so creating churn. That's why you, on the client side, can avoid creating too many connections by using connection pools. Nonetheless, the TLS negotiation is still very long, right? So it takes about 100 milliseconds. That's something that now has been offloaded to those enhanced I/O threads that Nigel was talking about, and that's a 300% improvement. And the other two that are extremely important, he was showing up the bars on the bottom, right? When you have more performance, you usually do a trade-off and everything gets slower, right? In this case, we're not. We're actually also being faster overall, getting up to P100, up to 90% faster. So those are extremely important, but because it's essentially an in-memory store used as a database, performance and observability are really, really important to look at. And we've added some commands as well to be able to have logs and stats that allow you to take a deeper look at your metrics.
I mentioned as well that we had modules that released for Valkey with 8.1, and it's a lot to have to negotiate which, install you're going to use using the binary and then like picking the modules. So we also have a release called valkey-bundle, which takes all of those modules and puts them together. And this wouldn't happen without all of the people who are supporting the project. I wanted to bring to light our modules. I mentioned them before, but I wanted to talk about them a little bit more. So we have a JSON module, which allows you to use JSON as a native data type in Valkey. We have a Bloom filter, which is a probabilistic model for being able to tell whether something is perhaps in a set or definitely not in a set. We have a vector search module, which allows you to do real-time vector similarity search inside of Valkey. And then we have LDAP authentication, which allows you to take your existing permissions and apply them to Valkey. Roberto's going to talk a lot more about each of these in more depth.
Thank you, Nigel. So first, I'll show you a screenshot of a use case. And this is where building community and having all those organizations really shines, right? First of all, this demo was created by someone at GCP, and then we keep adding more features to it, folks from the AWS, etc. Right? The idea is that community, like everybody working together to a goal, and that's where, in this case, it's a very simple demo where it shows two different people with different bios looking for the same search term. So that gives them similar but different results that are tailored to the personality of each one of those. For example, the one on the top, it's an indoor person, so that you get like more high-tech gaming kind of headphones. Someone who is an outdoor person, they will get more rugged or like running headphones. The way that we built it, and this is when it's going to show those modules that Nigel talked about. First of all, we provide recommendations using vector embeddings. Does anyone know what a vector embedding is? And have used a database? Yeah, someone. It's similar to, there are actually purpose-built vector databases. And there are a bunch of other relational databases that are taking ownership in providing that feature. That's something that they do very well as well, but they lack speed, right? The whole point of Valkey is that microsecond response time. In this case, vectors are, you have to go through an index, so probably you're going to get single-digit milliseconds. And the point here is that you get extremely high performance, and something that is very specific to this is high recall. That means this is the accuracy. It's not just the amount of requests that you can do, it's how accurate they are. And what vector embeddings do is they show you, or they help, if you have some data, then you can infer and find similar relevant data. In this case, like a song, and then you may find a different song that you may like. So with this approach, the vectors, this is just the products. So we're using an old data structure for the catalog of the products, and we have a flat schema. And then we're also adding the embedding below, that it depends on whatever embedding mechanism that you're using. There are different models that do this. And then the more dimensions, the better searches you're going to get, but it depends on the raw data. Those are good for audio, video, images, or things like that are unstructured and they have lots of dimensions. If you have more structured data, you may not need as many, and that means that you can use smaller ones like the 384 from this demo is using Tiny Llama. So the point here is that you can reduce the amount of memory that you're going to use, hence fit in more data into your single Valkey database. Now the next is JSON, and this is again one other proof of collaboration. This is a module that was created by AWS. They open source it. They say, hey, we have it. It's right here, right? Everybody can use it. And the main advantage is that you have now the ability to reduce the amount of network that you're going to use to store your data. That means if you can always store anything. Valkey is a binary string, right? So you can send as much data you want, up to 512 megs by default. But if you do have to do that from the client side, you have to serialize it and then store it as a string, send it over through the wire. So what happens if that's 1K, 10K, 50K, right? It supports up to 128Ks, megs. So that's going to be huge, and you're going to clog the network. So another problem is, what if you have to make a change? If you have to make a change, then you have to read the whole thing, make a little change, send it over, and then what if it's a product? What if you have a catalog of products and you have multiple different stores, and then you have to update just the quantity of how many products you have left on the stock? So for that, you have the JSON support and JSON path support. That means you can filter the data and only get the little piece that you need. In this case, I'm going to search for all my history of the products that I purchased that are between 100 and 200. And then the next thing is making an update on just that one little thing. Maybe I bought something and I say, it's not that good, and then, it's actually better, right? So I'm going to get a 4.5. The next is that Bloom filters, where Nigel mentioned that you have the ability to look at a set and probabilistically see if you have seen or not that element. You can always do that with anything, right? You can have a table on the relational database and then have a pivot there, the user and the product. And the problem with that is you're going to incur into large data set. Let's say you have UIDs for the user and the product. So those are going to be 40 bytes each. You have 80 bytes. Let's say you have 100,000 different products, 1 million users, and then 1 million purchases. Then you start getting problems into doing something simple. The way to do this and to make it really, really, really fast is by using a vector or a vector of bits that you toggle. The problem is you will need to have a bit per user per product, right? So a hashing algorithm that allows you to track, in this case, the X is going to toggle bit 2, bit 6, or whatever, and the bit 13. So that means that whenever I want to check if X is there, I know that E may be there. In this case, it really is, right? Because the 3 bits are set. If I look for an item B, for example, that is going to be bit 0, and the last bit in, let's say, the third bit, I have only 1 or 2 bits. That means that for sure I know it's not there. If all the bits are not toggled, that means we haven't touched those bits that there should be, right? And finally, if I look, for example, with, C, item C, okay, it's on bit 2, it's on, okay, bit 4, it's on, and bit 6 is on. But we haven't added it. So that's the why, right? That's a maybe. But for sure, you can guarantee no false negatives. You're going to manage the false positive rates by specifying how big your bit vector you want, and the hashing algorithms, how many by configuring by default the 1%, or you can reduce or increase the false positives. And with this, you can get up to 98% memory reduction. We have a blog that talks about the specific use case for ad tech, where you want to track which user have seen, for example, an ad, right? And this is how you do it. In this case, we have a very simple use case. We have that e-commerce website that we're tracking the products that each user has seen. As you can see, we just do is toggle it. And if we want to check, we just check, look at the exist command, and that's it. Fairly, very simple. And now, going back to the AI piece of this with the vector similarity search, like I said, the main thing here is that GenAI models use those vector embeddings that are binary values, numeric values, of a representation of the unstructured data. And how they do it, essentially, they go and find a vector that you want to start a search for, and then they go to the next level that's using the HNSW algorithm, and that those are layers. So it's going to reduce the amount of items that are going to be returned, in that essentially just like funnels down which elements are similar or relevant to you. But how do you manage that? It's fairly straightforward. All you have to do is take your existing data, that embedding, you create, in this case, we're doing a hybrid search. We create an index on products by using hashes. You can do this as well with JSON. So that's where your raw data is. Then you create the index, in this case, providing tags, which for strings, price, numerics, and the last one is the vector embedding that is using the HNSW with the cosine similarity for the distance between the vectors. And this is, again, very straightforward. If you see the previous command, that's the creation of the index. This is the search, where we're doing that FT command. And then all you have to do is provide the tags, right? That the text that we send it, the headphones or the laptop or whatever word we're sending. And on top of that, we have the user vector. That's the predicate, right? That's what makes this search unique, providing my preferences to the search to go and perform the query itself.
So none of what we talked about would be possible without the collaboration of the other companies. Like I said, we have systems in place for people to have their voices heard. Obviously, you can go online, file issues on GitHub, and get responses and contribute to the project in that way. But again, we have on our website, the valkey.io website, we have a Slack workspace where if you're interested, we can get you involved in, like I said, that engagement group meeting that we meet once a week and figure out how best to engage the community with Valkey. And then if you're interested in becoming a contributor or get on that path to maintainership as well, we can help coach you there. And then if you're interested in using Valkey, you have a Docker install, you can call valkey-valkey to get there. And then our GitHub repository is github.com/valkey-io.
Yeah, and giving credit to who deserves, right? So this search functionality that we talked about was done by GCP. The LDAP module was owned by Percona. They are a database company, but they also do a lot of consultancy. So they had customers who wanted this integration that was never available. So it's an open community. It's open source. They say, hey, we have someone who wants it. We have someone who wants to build it. Here it is, right? We all contribute to make this the database that's going to allow you to lower your performance, increase your performance, lower your latency, and reduce your cost as well. When all of these features that we're doing, increasing the performance, that means fewer boxes, lowering the amount of memory use, that means smaller boxes, right? So you're cutting down costs just by upgrading to Valkey. And we hope to see you on the Slack, ping us on LinkedIn as well. Anything helps, not just this, the Valkey project, but any open source project. It could be Postgres, it could be Kubernetes, whatever it is. We hope you go tomorrow and start exploring something that you like and start contributing.
Like Megan said earlier, people get involved in projects with problems that are specific to them, like Roberto was talking about with Percona and LDAP and their customers. So if you get to using Valkey and you find a gap, that's the things that we want to hear about. And then we can add you to being one of the people who are contributing to the project. So thank you so much. Do we have any questions?
Big applause, please. Thank you, thank you. Si tienen preguntas, anímense, no hay problema, podemos traducirlo, seguro. Ahí, Roberto. No te mic, ahí está.
Sorry. You mentioned that this project is being supported by several cloud providers. Mm-hmm. It is possible to have this project as a service soon?
Mm-hmm. Yeah, it's available as a service now on Oracle Cloud, on Google Cloud, on AWS, UpCloud, Nextcloud,
Avon, DigitalOcean, Huawei, Alibaba, Tencent.
Yeah, there are a lot of cloud providers that are providing Valkey as a managed service today. That's not something that you have to wait for. Yeah.
We have here another question.
So I'm just curious about the use case in game development. So I asked you in your book about I have a project like it's a test MMO kind of thing, right? I'm thinking like 500 players, but maybe more. So there's a lot of modules that other companies are doing. So is there any game development actually happening right now in Valkey and modules that I can use, test, and all this stuff?
That's a great question. There is a lot of game development that's happening on Valkey. I don't know that we have any sample code available online. If that's something that you're interested in, that would be something to bring up in an issue on GitHub or in the Slack, and then we can try to connect you to the people who are doing what you're trying to do, and then figure out how to get you some sample code or some more explanation of that specific use case.
But I've seen it firsthand. I got to work with a lot of companies who do that, and there wouldn't be any global gaming without Valkey, right? So just think about that. Every major system that you ever played it's probably using it. There are specifics. For example, there's a data structure that allows you to do leaderboards. You can do leaderboard with a relational database, right? There's no problem. It's a table, and then every time that somebody makes points, you just keep updating. The problem is what happens when you reach the limit of what the relation is going to do. Let's say you have 1 million players, and then you're doing a select or star from table descending on points, right? Like very quickly it's going to break. You have to start splitting the table, and you have to say, okay, well, I have this user ID, it's a UID, so I use a hex, so you have 16 values. You have to make 16 different tables, get the top of each, then mix them, then send it over, right? That's ridiculous, and that's what the real-time in-memory database is going to give you.
We do have one demo that if you come to the booth tomorrow, we can probably show you, or I'll find it on GitHub for the leaderboard case that Roberto's talking about. We have a demo and some sample code about using Valky as a leaderboard. Yeah.
Awesome. We have time for one more question. Yes, there. The mic.
The mic.
Oh, stop, please. Wait a minute.
For the folks on the line.
Thank you.
Online.
Yeah.
Thank you for the talk. I heard Valky could be used as a message queue.
Yeah.
We were using RabbitMQ for a while, which I understand is an older, it's been around for a while. My question is, what are the things that I should compare between the two if I'm considering moving from RabbitMQ to Valky for
I can take that one. Yeah.
Okay.
So you can dig through YouTube. There's a talk about this specific use case, right? So RabbitMQ is actually great, right? It has a UI. There's a bunch of support in it, but the problem is scalability, right? Like it's really hard to maintain a large cluster. That's why by default you only see Rabbit 3 server RabbitMQs.
Yeah.
Valky, right now it supports up to 500 nodes in a single cluster, and very soon it will support up to 2,000, right? So essentially the idea of having a distributed database is that you shard the data, and then you have smaller nodes that are doing the job that they need to, right? So there's two different ways of doing it. There's bulky lists that are linked lists, double linked lists that you can use, but it also has streams. So similar to Kafka, so you can have consumers and consumer groups, and that way you can determine whenever an item has been acknowledged or not.
Thank you.
Thank you
very much. Thank you, Robert. Nigel, please, big applause again.
Gracias.
Y nosotros ya seguimos con mucho más de Nerdearla. Dale. Gracias.
Hay infinitos caminos por recorrer, infinitas rutas a seguir. Pero si no encuentras tu ritmo o partners que se muevan contigo, no tendrás ritmo que seguir. Con Red Hat puedes elegir. Así que puedes ir a donde quieras y transformarte según tu estilo.
Introducing tests for 11 Labs agents. With 11 Labs agent testing, you can rerun saved conversations to validate your agents before they reach production. Create tests from scratch, or generate them automatically from real conversations. Ensuring that your agents respond correctly, trigger the right tools, or hand over to a human when necessary. Agent testing integrates directly into CI/CD pipelines, so every agent update can be run against large-scale scenarios. So start building and testing today with 11 Labs.
Client started out as a way for hobbyists to push the best models to their full potential to see what they're capable of. We quickly found engineers using it to get serious work done.